Hello everyone. In this video, we are going to see all about Apache Iceberg. In the world of big data, managing massive dataset in data lake is always been challenging. Apache Iceberg is one-step solution for these challenges. Iceberg is originally developed by Netflix and it is now part of Apache Software Foundation. It is an open table format built for managing large-scale data lake tables. It solves the ACID limitations on traditional file formats like Parquet, Avro, and ORC. It enables reliable DML operations, transaction control, and schema flexibility in data lakes. Apache Iceberg is designed for high performance, data correctness, and easy to use in analytical environments. Apache Iceberg has many features that makes it ideal for modern data lakehouse architecture. Some of the key features of Apache Iceberg are hidden partitioning. Iceberg handles partitions internally and simplifies query and boost performance without user intervention. The next key feature is schema evolution. Changes in the data is inevitable. Iceberg embraces it. You can add, drop, rename, or reorder columns without rewriting the full dataset. Need to query yesterday's data? Iceberg comes with time travel feature. You can query historical snapshots for audit and rollback. Another feature is full snapshot isolation. Iceberg guarantees ACID compliance for read-writes through snapshot isolation. Apache Iceberg is file format agnostic. Iceberg works seamlessly with some of the common formats like Parquet, Avro, ORC, etc. The next feature is metadata management. Are you working with petabytes of data? Iceberg manages metadata separately and effectively. It ensures faster query planning and optimized read-write paths even with massive amount of data. Now let's see the architecture of Apache Iceberg. Apache Iceberg organizes tables using three-layer architecture. The first layer is catalog layer, the second layer is metadata layer, and the third layer is data layer. The catalog layer is at the top of the Apache Iceberg architecture. It stores the current metadata pointer for each table. The catalog layer acts as a registry to manage and locate Iceberg tables. The catalog knows which metadata file is most relevant and serves as an entry point for read and write operations. The next layer is the metadata layer. The metadata layer has three components: metadata file, manifest list, and manifest file. The metadata file contains the table schema, partition spec, snapshot history, and reference to the manifest list. Manifest list points to one or more manifest files. It contains the reference to the manifest files. The next component is manifest files. Manifest file contains information about row counts, partition value, file path, min and max values, and null counts for each column. Metadata layer helps effectively plan queries and tracks file level metadata without scanning the entire dataset. The next layer is the data layer. The data layer is where the actual data file exists. The data layer consists of data files. The data file stores the table content in formats like Parquet, ORC, or Avro. The files are immutable, which allows versioning and safe concurrent operations. We will see a practical implementation of Apache Iceberg in Azure Data Lake Gen 2. Now let's see how to provision Apache Iceberg in Azure Synapse Analytics. Some of the prerequisites are: you need to have an Azure subscription, a Synapse Analytics workspace, a storage account and a container, and an Apache Spark pool which is up and running. In order to provision the Apache Iceberg, you need to upload Iceberg package in Synapse. Next, we need to attach the package to Apache Spark Pool. Next, we need to configure Spark session for Iceberg catalog in ADLS. The last step is to create and query the Iceberg tables. We will see the practical implementation of all these steps. Here is my Azure homepage and I have a storage account test DL fetus. Inside that I have a container. My container name is Iceberg. Currently my container is empty. I don't have any files or folder inside my container. And here is my Synapse Analytics workspace. The first step is to upload the Iceberg package in Synapse. In order to do that, let me go to Manage. Inside Configurations and Libraries, we have Workspace Packages. I have already uploaded my Iceberg package here, and here is my package. This is a jar file which we can download from Maven. I will give the link to download the jar file in the description. Once you have uploaded, you need to wait for a few minutes to have the provision status as succeeded. The next step is to attach this package to Apache Spark Pool. In order to do that, I'm going to Apache Spark Pools. And here is my Apache Spark Pool which is up and running. In this Spark Pool, let me select packages. And we need to select the package that we uploaded. And we need to click Apply. Once we click Apply, the Iceberg package will be attached to Apache Spark Pool. The next step is to create the Spark session. Let me go to Notebooks and open this notebook. As a first step, I have set up an Iceberg catalog named Hadoop Cat, and I am configuring the catalog to use Hadoop compatible file system. In our case, the file system is ADLS Gen 2. Next, we are specifying the storage account name and the container name. Here is my storage account name and here is my container name. I am creating a Spark session with this configuration. Let me run it. My Spark session is up and running. Next, in the Hadoop catalog, in the default namespace, I am creating a table called test iceberg table, which has two columns, ID and name. ID is of type int and name is of type string. And this table is of type Iceberg. I am creating this table using Spark SQL. Let me run it. My table is created. Now let me go to the container. Let me refresh. We have a default folder got created. Let me open this folder. And we have a folder with the table name. We have a metadata folder. Let me open this folder. We have version 1 metadata.json, which has the metadata information. Let me open this file. Here is the metadata information. And we have version hint.txt. We have the value 1, which points to the current metadata. Our current metadata version is 1. So hence we have the value as 1. Now let me go to the Synapse Analytics and insert few records. I'm going to insert 2 records. And I'm going to select these 2 records. Let me run this. We have inserted 2 records in the Iceberg test table. Now let me go to the container. Let me go back to the Iceberg folder. Inside the default folder, let me refresh. We have a folder with the table name. Let me go inside this folder. Now we see 2 folders got created. One for data and the other one for metadata. Let me go to the data folder. Inside this, the data will be in the Parquet format. Now let me go to the metadata folder. We see that the manifest file got created, which is in Avro format. The next file is the snapshot manifest file. Sorry, the snapshot metadata file, which is also in Avro format. The snapshot metadata file reference to the manifest file. We also see that there is another version got created since we have inserted couple of records. Let me go to the version hint file. If you see here, it has the value 2. The version hint file points to the latest version of metadata file. I hope you got a fair idea of Apache Iceberg and the practical implementation of provisioning the Apache Iceberg in Azure Synapse Analytics. And I'm sure that you learned something new today. If you do like this video, please consider to subscribe and I will see you in yet another interesting video. Thank you.